Our next skill we're going to be looking at is called rationalizing the denominator. So something is rational if it's a rational number, like 2/3 is a rational number. Square root of 5 is not. That's irrational. So if I want to rationalize it, in other words, I want to get rid of the irrationals. So expressions are not considered to be completely simplified. Right? When they say simplify completely, simplified, if they still contain a radical in the denominator, so on the bottom. The act of rationalizing, in other words, removing the radical, remove the radical, get rid of this square root part. That's called rationalizing. If you remove the radical from the denominator, this is called rationalizing the denominator. So it is actually something we will be using in other places too. So there's going to be two cases. First off, there's the easier one, an expression that has a monomial. In other words, one term, a monomial square root denominator. What I'm going to do is I'm going to multiply both the top and the bottom, so the numerator and denominator. So both the numerator and the denominator, I'm going to multiply by that radical term. What? Hang on, show you what I mean. Let's say you've got this, 5 over 2 times the square root of 3. Now, this is not simplified because I've got this root in the bottom. So I want to get rid of that root. It's the root 3 that I need to multiply by. So here's what I'm going to do. If I multiply by like 5 over 5, that's 1, right? Or 2 over 2, or 8 over 8. Any number over itself, I'm multiplying by 1. So I'm going to multiply by root 3 over root 3. That's multiplying by 1, which means, okay, I'm not really changing it. I'm just changing the way it looks. Okay, look what I get. 5 times the root of 3 is 5 root 3. On the bottom, I get 2 times root 3 times root 3. In other words, I get 2 times root 9. Now, hang on. The square root of 9 is 3. So this is like 2 times 3. The bottom just becomes 6. And the top is 5 root 3. So that's considered to be simplified. I mean, this one has a root on the bottom. This one has the root on the top. It really doesn't look that much simplified. However, this would be considered to be simplified because you want to get rid of that square root on the bottom. This all goes back to the idea that if this is an ugly, weird, strange number like 1.716289 something, it's way easier to multiply by an ugly decimal than it is to divide by an ugly decimal. That's why this is considered to be simplified. Now notice I didn't multiply by 2 root 3. I multiplied by root 3. The 2 is already rational. That's 2. 2 is a rational number. It's okay. Root 3 is an irrational number. That's the one I want to get rid of. So that's what I want to do. I want to multiply top and bottom by the thing that I want to get rid of. So watch over here. This thing is not simplified. I've got root 6. That's what I want to get rid of. So you know what I'm going to do? I'm going to multiply both the top and the bottom by the root of 6 because I'm multiplying by 1. Because look, when I do it on the bottom, it becomes 6 times the square root of 36. So the bottom becomes 6 times the square root of 36, which I know, remember, I'm not going 6 times, no, it's just root times root, 1 times 6. This becomes 6 times 6. The bottom becomes 36. It's a number. It's not a square root. It's a number. What about the top? Okay, root 6 times here, so this is 7 root 6. And then root 6 times 3 root 3, 3 times 1 is going to be 3 root 6, root 18. Okay, so this doesn't really look simplified. It looks bigger, but this will simplify. I know this is going to be 6 times 6. I recognize this. Oh yeah, that's root 9 and root 2. What do we got? So this becomes 3 times the square root of 9 times the square root of 2. Root 6 doesn't break down. That's done. Okay, so here's what we have. We have 7 root 6. Remember the denominator we said is 6 times 6? In other words, it's 36. What does this one become? 3 times 3, so 9, root 2. Now, can I add these two together? No, they're different kind of radicals. They're done. This is simplified. That's as far as you can go. There's nothing else I can do here. Whoa, what about this thing? This thing has no numbers. Hang on. What is it that I want to get rid of? I want to get rid of the D on the bottom, not the B. It's okay to have a radical on the top, but they want to simplify it. They want to get rid of it on the bottom. So, multiply top and bottom by the square root of D. I always do the bottom first because it's easier. Root D times root D, that's D. So this is C times D. C, D. What about the top? It's a times the root of b times the root of d. Okay, so that's just the root of bd. B times d. I don't know what that is, but that's done. See, the radical is on the top now, not on the bottom. This doesn't really look simplified, but it is considered to be simplified. Now, this one's not going to work. Here, watch. I'll show you why. I'm going to do it wrong first, and then you're probably going to see, oh, I see it. So let's make ourselves a little bit of room. What do I want to get rid of? I want to get rid of the cube root of 4x. So let's multiply top and bottom by the cube root of 4x. And watch what happens. It's not going to work. What? No, it's not. Because when I multiply by the cube root of 4x, look, the bottom becomes 4 times the cube root of 4 times 4 is 16. X times x is x squared. That's still a radical. It didn't disappear, right? It's not the square root of 16, it's the cube root of 16. Oh yeah, so for the cube roots, remember, I want to think about what are my cube roots. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. I wanted this to become 8, not 16. Oh, and yeah, cube root of x squared, that's no, but if this was an x cubed, that would have simplified. So I wanted to make this an x cubed. That's my target. And I don't want this to be 16. I want it to be 8. That's my target. So you know what? This doesn't work. 4 times 4 gives me root 16. That's still a radical. I got to think about what my target is. What am I trying to get to in order to simplify it? So let's try it. If it's a cube root, it's a little bit harder, right? I'm going to multiply top and bottom by cube root. I want to turn it into 8, so I'm just going to multiply by 2 on top and bottom, because that'll make this 8. Good. And this is an x to the 1. I need this to be 3 x's. I'm going to multiply by x squared. Because now what happens? Now, notice I didn't multiply by the same thing. I multiplied by something different. But look what I get. The bottom becomes 4 times the cube root of 4 times 2 is 8. I know that's going to simplify nice. And x times x squared is x cubed. I know that's going to simplify nice. What's that going to turn into? I can kind of see that the next step, the bottom becomes 4 times 2x. So in other words, it becomes 8x. That's not a radical. That is rationalized. That is beautiful. It's great. The top, well, yeah, top's not going to be fun. It's going to be hideous. It's going to be, but we don't care about the top. 5 times the cube root of, okay, so it's 5. I'll do it over here. 5 times cube root of 2x squared, which doesn't simplify. It's not the square root, it's the cube root. And then the cube root of this and cube root of this. Okay, so plus cube root of 10x squared, cube root of 20. So this is the cube root of 20x to the 4. Cube root of 20 doesn't break down. It's not 8 times something. It's not 27. No, but the x to the 4, right? If there's 4 x's in there, 1, 2, 3, 4, I can take out 3 of them and it shows up out front. So that does simplify. 5 times the cube root of 2x squared plus x times the cube root of 20x. Yikes. That is simplified. It doesn't look simplified, but this would be considered to be simplified. That's a pretty difficult question. Okay. Now, remember conjugates? Conjugates meant there are 2 binomials. This is where they're the exact same, but one's a plus, one's a minus. And when you multiply them all out, right? If I squared this all out, I know I can do FOIL, right? We know we're going to get x squared minus 5x plus 5x minus 25. Those middle 2 always cancel. They do. Always, because one's a plus, one's a minus. So here's what you end up with. You end up with x squared minus 5 squared. X squared minus 25. It's a difference of squares. Oh, I remember that. So it's a square minus a square. If I was to multiply this all out, I could. And I know the middle 2 are going to cancel every single time. Here's my shortcut. A squared minus b squared. Is it always a minus? Yes, because b times minus b is minus b squared. It has to be minus. If this is a plus, it doesn't factor. It's got to be a minus. Okay, so I can use that shortcut and think about if I'm multiplying out to skip a few steps. 5 plus root 3, 5 minus root 3. Remember, it's a squared minus b squared. So it's 5 squared minus root 3 squared. Now, 5 squared is 25. Root 3 squared is not 9. Root 3 times root 3 is 3. So this whole thing becomes 22. What about here? I think in the notes, yeah, I probably have it wrong. I think in the notes I've got it as root 3 squared is 9, but this should be 22. Okay, let's see. What do we got? 2 root 6 times 2 root 6. 2 times 2 is 4. Root 6 times 6 is 36. So it's the first one squared, right? Minus root 20 times root 20. Root 20 squared is 20. Okay, so this is 4 times 6. This is 24 minus 20. In other words, it's 4. This whole thing simplifies down to the number 4. That's beautiful. It's way easier. This is going to be kind of ugly itself, but it'll still work. Let's try it. 2x times 2. So it's going to be 2x squared minus root x squared. It's a difference of squares. It's a square minus a square. 2x times 2x, 4x squared. Root x times root x, x. Done. Now, if you really want, you can factor out the x. Ooh, look at me, I'm factoring 4x minus 1, but who cares? They're the exact same thing, right? We know that this is really the same as this. I would consider this actually be simpler because it's got no brackets. I like it with no brackets, but yeah, you might see it written this way. Who cares? These are identical. Here's the important thing. See all these answers? None of them have roots. None of them have radicals in it. So what we did is we got rid of the radicals. So that's the second kind. If you have a binomial denominator, so in other words, if it's got two terms, something plus something or something minus something, it contains a square root. I'm going to multiply both the numerator and the denominator by a conjugate. The conjugate? Why? Because you remember, if I get a square minus a square, I get the product is rational. In other words, it has no square roots in it. All the radicals disappear. The product turns out to be rational. How come? Because remember, it's a square minus a square. It's something squared minus something squared. And when you square it, those radicals disappear. Now, we're not going to do this for cube roots, just square roots. Okay? So let's try this. Root 5 plus 7. Now, I need to multiply the top and bottom by the same thing. It's going to be root 5 minus 7. Why not plus? Before we were multiplying by the same thing. Now I'm multiplying by the conjugate. Here's why. Let's do the bottom first. The bottom's easier. Root 5 squared. Root 5 times root 5. 5. Minus 7 squared. 49. The bottom became negative 44. It's a number. It's negative 44. The top, not so nice. It's going to be 11 times root. Okay, so 11 root 5 minus 11 times 7 is 77. Okay, but there's the only radical now. So let's see. Here's what we got. 11 root 5 minus 77 all over negative 44. That's kind of done, or is it? Hang on. Notice this is divisible by 11. So is this. So is this. If I can factor out 11 and cancel the top and bottom, I probably should. So let's do that right now. Instead of minus 44, I'm going to say this is minus 4 times 11. See the 11? It's a number. This is a number. That's a radical. If I can divide out 11 from both of these, and I can, right? It's 11 root 5 minus 7. If I think about it, right? If I factor out the 11, just like factoring out an x, the 11s will cancel. So really, what am I left with? If the 11 cancels, here's what I'm left with. I'm left with root 5 minus 7 all over minus 4. That is considered to be simplified because, see, the radical is no longer on the bottom. Now it's on the top. And this is pretty simplified. Now, you might also see this negative 4, they throw it on top, and they'll write this as minus root 5 plus 7 all over positive 4. Who cares? Those are the exact same answer. They really are. You can, remember with a negative, you can either put it on the bottom of the fraction. If you don't want it on the bottom, it comes up on the top, but it goes onto both of them. So minus and minus minus is plus. Who cares? These are identical. These are the exact same answer. Okay, let's try this one. 6 over the square root of 4x plus 1. So I'm going to multiply top and bottom by the square root of 4x minus 1. Square root of 4x minus 1. I'm going to do the bottom first because the bottom's easy. This one's squared. Root of 4x times root of 4x. Think about it. The square root of 4x, if I square it, it just becomes 4x. Right? Because the square and the square root cancel. minus 1 times 1. 1 squared is 1. Done. The bottom is just 4x minus 1. And the top is 6 times the square root of 4x minus 6. I know that'll become 2. So this is really 6 times 2 times root x. Yeah, that's root 4 root x. So 6 times 2 is 12 root x minus 6 all over 4x minus 1. I think we're done. I can't cancel individually. No. I could divide out 6 here, right? However, think about it. 2 root x minus 1. It doesn't really... 4x minus 1. It doesn't really simplify, so there's kind of no point in dividing out the 6. So, I mean, yes, you could, but it doesn't really simplify, so don't bother. That's done. Yikes. Look at this beast. Maybe we should try and simplify this thing at first. 4 plus 4 root 4. Hang on. 4 root 4 means 4 times 2, which is 4 times 2 is 8. So the bottom, the whole top just became 4 plus 8. It's really 12. What's the bottom? It's 2 plus 2 root 2. 2 plus 2 root 2. Okay, let's multiply top and bottom by 2 minus 2 root 2. All right, I have to use the conjugate. Here's why. Let's do the bottom first. It's going to be this thing squared minus this thing squared. So this squared is 4. That's easy. Minus 2 root 2. So hang on, 2 root 2, if you think about it, 2 root 2, if I square it, I'm going to get 2 squared, which is 4 times 2. 8. The bottom just became 4 minus 8. Oh, hang on. Let's back that up a little bit here. All right. 2 squared became 4. 2 root 2 squared. And if you're not sure, plug it into a calculator. This is like 2.4 some weird number. When you square it, you get 8. The bottom just became 4 minus 8, which is negative 4. Okay, but let's do the top. 12 times 2 is 24. Minus 12 times 2 root 2. So 12 times 2, which is 24, root 2. There's still a root 2 on there. This is a number with a radical. I cannot combine these two. These are two separate things. But this is minus 4. Okay, so what do we got? 24 minus 24 root 2 all over negative 4. Now, if I really wanted to, I could break this up as two different parts. Look. 24 over negative 4, that becomes negative 6. And then this one. Because I can break up a fraction in two different ways like this, I can do that one and then this one. Minus 24 root 2 over minus 4 is plus 6 root 2. That's done. That's about as far as I can go. Okay, one last one. Let's give it a shot. 5 plus the 2 root of 15, 5 minus the root. This is what I want to get rid of. So instead of 5 minus root 15, I have to multiply top by 5 plus root 15. So it's got to be top and bottom. Otherwise, I'm changing the question. So I multiply by a weird form of 1. That's what this is called, a convenient form of 1. So I'm multiplying by 1. The whole idea here is that the bottom is going to simplify. The top's going to get ugly. It's going to be hideous. I know that. I know that for a fact. So let's just do the bottom first. 5 times 5, 25. Root 15 times root 15 is 15. Guess what? The bottom just became 10. That's really nice. Okay. What about the top? I have to do a binomial times a binomial. This is going to be FOIL. 5 times 5 is 25. 5 times root 15 plus 5 root 15. 2 root 15 times 5 is plus 10 root 15. And 2 root 15 times root 15, sorry, it's going to be 2 root 15. Root 15 is root 225. I know that's going to become 15. Okay, hang on. Let's simplify what we can. This is 25. This is 2 times 15. This is 30. I know that's going to become 55. What do I got? 5 and 10. I got 15 root 15s. And the whole thing is over 25 minus 10. Okay, so what do we got? 55 plus 15 root 15, all divided by 10. Now, is that done? Notice this is a number, this is a number, this is a number. If the numbers are all divisible by 5, and they are, don't worry about this. This is not a number. This is a radical. It's different. But if I can divide out 5 from all 3 of them, it's just kind of like breaking them up individually. I can divide out 5 there. I can divide out 5 there. Let's factor out the 5. And let's see. I would get 11 plus 3 root 15 all over 2. 11 and 2 and 3. No, that's done. So rationalizing the denominator, it's the denominator that you want to get rid of the square root. And here it becomes a number. And sometimes it'll simplify even further. The top could get bigger and uglier, but that's okay. We don't mind the top being big and ugly. It's the denominator that you want. Okay, so page 291, here's the first few to get started with.